Hello, everyone. My name is Daisuke Kuramoto. Today I talk about playing with AI, exploring face tracing through physical and digital mask making. Let's go. Again, uh, listen. I'm currently a project researcher at the University of Tokyo and organizing Otomo coding community and Tento after school coding class for kids and so on. Please remember me, Dice and K, Dice K. Today I share about a workshop exploring face sensing through physical and digital mask making. First of all, about talk about the background. Children are starting to use smart devices at younger and younger ages. For example, they may watch adults making video calls or make calls to friends and family together with their parents. At the same time, there is growing interest in not just using AI, but understanding and even making with it. So I started wondering, how can we create meaningful, fun, and critical experiments of AI for children? We know one tool I found very promising is the face sensing extension in ScratchLab. It's easy to use, safe, ethically designed, and fair for all children. But just playing inside the scene, inside the screen, felt a bit too disconnected from their real lives. So we thought, what if kids make virtual masks in Scratch and also physical masks in real life? We have simple shaped stamp for use. It's its shape similar, making shapes of sprites. Making analog mask first as a scaffolding. It's familiar, playful, good for ice breaking, and gives kids a sense of commitment and ownership. It also makes the virtual experiments feel more grounded in the real world. But we have barrier. Of course, scratch blocks are in English, especially in the experimental labs version. Yes, we are Japanese. So we built a simple sample project where, where kids can play with their face. It shows shows the part of uh, face, and they point their nose or light eyes or something. Do that. I have a link on slide. Please visit the project. And we prepare the sheet of translation of those face parts name. From now, reporting. We ran the workshop with young children. Here are some snapshots. You can see them enjoying both the hands-on making. Of course, it's familiar to play, and they can mask create it. Finally, everyone made paper masks in the very short time. Next, digital part. Something digital-like happened. It was a fresh digital experiment. We saw they comparing the physical and digital version. Something very digital-like happened. The stamps are set in that size, but he drew freely to make a big mouth in sprite, the light one. From what we observed, children, children were fully engaged in both real and virtual mask making, and they compared how their mask looked in both spaces. Some even hacked their virtual masks, like on this picture. She tried to hack with uh, her drawing. Of course, it works. Her virtual mask wearing the her drawing on the paper, and they tried out each other's masks, sharing, laughing together. These experiments are small but meaningful. Through play, children aren't just using AI, they are encountering it, questioning it, and transforming it. By connecting physical, creative, physical creativity with digital sensing, we build a new relationship between humans and AI. Thank you for listening. This workshop cooperation with Canvas and uh, Eriko and Yashi help me with reflection meeting. Thank you for listening. Let's keep making strange and smart and joyful things together. Thank you.
Hello, I'm
Hi
Herman,
everyone, I'm Yasin.
and we're here to present this Ignite talk called Are or Not. This is a talk exploring Scratch and combining it with the Sustainable Development Goals. We are Digital Moment, a nonprofit organization based in Montreal, Canada, and we serve the whole country, teachers and uh, students. My colleague Yasin.
Hi everyone, I'm Yasin. I work with Digital Moment as an instructor where I can do workshops with youth and teachers around digital literacy. In my everyday life, I'm a software engineering student here at McGill University, Montreal, Quebec, and I'm working in cybersecurity with the Quebec government. Thank you. I'm happy to be one of your presenters today.
Perfect. Thank you, Yesin. My name is Herman, and I'm the program and training manager here at Digital Moment. And I've been with Digital Moment since 2019, delivering many workshops across the country in many different places in many different technologies. So let's see what these are or not is about. The reality is that we've been working with Scratch since 2012 and trying to help teachers, students, and parents to engage with technology. We want people to have a digital literacy approach to their lives. And we do this via three different channels with Scratch. One of them is that we do teacher training. So we go and we support teachers with materials and professional development sessions so they feel comfortable about the technology, they feel comfortable implementing, making mistakes, and creating new things. We also have run thousands of workshops across the country in person and online, helping kids explore, helping them become creators, helping them become thinkers, critical thinkers, and computational thinkers so they have the tools and the framework to solve problems and tackle opportunities. And we also support and manage Code Club for Canada. So all the resources and the wonderful code clubs that we have all over the country, they are using Scratch and the technologies that we love. So those are the things that we have been doing, but we're seeing that in those technologies, especially in Scratch, we can use it as a vehicle to tell stories, to do exploration, to make curricular connections, to learn about different topics. And one of those we're very passionate about, and those are the SDGs, the Sustainable Development Goals. And we have a program that is called Digital 2030. Every year, we launch a new challenge that invites teachers, youth, and parents to think about the sustainable development goals and how can we be part of those solutions, and how can we invite or envision technology within those solutions. We are using also Scratch within Digital 2030 Challenge to make sure that we can reach a great number of people and we can include kids so they can start thinking about the world we live in and how can we make it better. We have run challenges on the plastic pollution, how to understand the practical plastic pollution and how can we collaborate, how technology plays a role, how data plays a role. We run a challenge on good health and well-being, focusing on us being better mentally and physically to be able to support each other, and reducing inequality, finding ways to make the world a little bit more equal, a little bit better for all of us. 2024 being the challenge for 2024 to 2025, we launched the challenge called the circular economy. And this is all about about responsible consumption and production. And all of us are consumers, many of us are also producers. And what we try to see here is how can we use less resources or use our resources a little bit better, and how does consumption play a role within that environment. It all starts with three words that start with the letter R. And those are words that we have said and we have learned for many years, and they are reduce, reuse, and I can hear it from all over the world. You're saying recycle. So, those are the three words we used in the past, but the circular economy embraces more words that use the letter R. Those are rethink, refuse, repurpose, and rot. And we wanted to create an activity that will help teachers and students explore how to work with those words. And Yasin is going to tell us all about that activity.
So what is exactly this whole or not Scratch game about? So or not is really a story. It's a story in the format of a quiz game. So Terra, our Earth character, is really the first one to engage the discussion. She'll welcomes the player and she'll reminds us of the R's that we already know. Just as Armand said, reusing, recycling, reducing, we know them. But Terra wants us and it needs us to go even beyond this. So this is where all the fun begins. Whenever you click on one of the green buttons, you're gonna get asked by Terra a false or true question surrounding one concept around the new R word. So, for example, if you click on the second button, Terra might ask you an example of rethink is to borrow books from the library instead of buying them. True or false? If you get the right answer, Terra will open her big smile and she'll be happy to explain why you were right. If you had the wrong answer, no worries, Terra is really nice. She'll take time to explain to you why it was the wrong answer and what could you improve. So really, each one of the three buttons, they correspond to one R word. So we have brought, rethink, and refuse. And we chose these three specific words because usually they are a lot less familiar, not well known, and also they open a way for tangible action that youth can really take as we talk right now. So, for example, when I'm talking about refusing, it makes youth realize that recycling is great, but if we can stop the waste at the source, it's even better. So, for example, they can refuse to buy a new smartphone when they have one that already works. So just as they feel more empowered to take a better environmental decision, they can also feel more empowered through the coding when it comes to digital literacy. So quiz game are really excellent games to develop our understanding for conditionals. So how can my game take different path, or also for events. So how can my game respond to player interaction? And obviously, we always provide them with starter code and detailed instruction to help them, to give them the support they need to walk out with a meaningful project. These instructions are really built in an incremental way, so they can build the game level by level. And also, we even provide videos for the more visual ones. And beyond these instructions, we also provide extra missions so they can explore more advanced computational thinking skills or advanced functions of Scratch. So, for example, variables for a score counter, for example. And we believe that coding is for everyone. That's why our resources are in English and also in French. And once the youth has finished coding their R or not project, the beauty is that R or not can really be anything. It can become a quiz on their favorite movie, their favorite character, favorite science topic. They can transpose those new skills to create really a new game beyond this one that they will be proud to show, for example, to their friends, their family. That's really the magic around Scratch. So before we wrap up, I'd like to thank you all on behalf of Digital Moment for joining us today in this moment of innovation and idea sharing. If you want to learn more about us or just stay in touch with us, you can always visit our website or you can email my colleague Herman with the email on the screen. Thank you, everyone, and enjoy your time at the conference today.
Thank you.
Hello, everybody, and welcome. And thank you for joining Tiny Hands, Big Ideas, telling stories with code and a creative learning spiral. My name is Guadalupe Gomez. I am the CEO and owner of Code and Play in Buenos Aires, Argentina. I am a kindergarten teacher who has specialized in educational technology, coding, computational thinking, and STEAM. And Code and Play is the result of more than 20 years of experience. And I love sharing creative and innovative ideas with educators around the world. Today, we're going to explore how to plan coding activities with Scratch Junior for young learners using a powerful idea by Mitch Resnick called the Creative Learning Spiral. When young children code with Scratch Junior, they are not just learning about technology. They are playing, imagining, and creating. Coding becomes a new language for expressing ideas, telling stories, and solving problems. But for this to truly work, our planning must nurture creativity and exploration. That's where the creative learning spiral comes in. A powerful framework for understanding how young children learn through creative coding is the creative learning spiral. It has 5 stages. First, we imagine. Children have an idea or a dream. Then they create. They make something based on that idea. Then things get a little bit messy. They play, they try it out, experiment, and see what happens. But at school, we share moments of play with others. We get feedback or present our project to others. Then we have a reflective time. They think about what worked, what they could change, and then they imagine again. So it's a spiral, not a straight line. Each loop builds new skills. For young learners, learning happens best when they can explore freely and revisit ideas. Scratch Junior is perfect for this. Kids move colorful blocks to make characters dance, tell stories, or solve challenges. When we plan lessons, we're not just teaching coding blocks. We are designing spaces where kids can imagine, create, play, share, and reflect. So, how do we do this in practice? First, we ask children to choose a background. Choosing a background sets the scene. It's where the story will come to life. Then they will personalize the sprites. The characters are the stars of the story. Picking, editing, or even creating their own characters help them express ideas, emotions, and actions. And then comes the coding blocks. Blocks are the magic behind the scenes. They make your story move or speak and interact. So I designed this template for the students to first work in an unplugged way. They have to think what's the plot of the story, which characters they would like to use, and then they will try to anticipate which coding blocks they will need. Let's see an example. Imagine we want children to create an animated story about a garden. First, they will imagine. We start with a question. What happens in a garden? We encourage kids to share ideas. Plants grow, bugs crawl, the sun comes out. Then they will create. Choose the characters, for example, a flower, a bee, the sun itself, and they build a simple scene in Scratch Junior. They play, they program the bee to fly around the flower, they test, does it move? Does it stop where I want to? They experiment. Finally, they will share their animation with others. They, they will show the projects to a friend or the whole class. Maybe they can add a sound or a new character because somebody suggests it. Together, they talk. What did you like? What was tricky? What could you add next time? And then they are ready to imagine again. So these are examples of an activity I've done with preschoolers and first graders. So students imagine the plot of the story and the characters they want to use. They even organized themselves. They worked in pairs, so they decided who was going to take care of each of the characters. Hachu is going to take care of Kali, Quit, Clappy, and Awichi. And then they even decided the title of the story. In this case, is Pájaros en Acción, or Birds in Action. So what characters would you like to include? What will they do? They start creating. They have the unplugged paper for them to write down ideas, and they have the tablets for Scratch Junior to be used. They go back again on their animation, not just on one day. We keep this activity in 2, 3, or even 4 or 5 days. So they go back to their animation and they change things while they go back to their unplugged paper and write more ideas. I'm going to show you a little video of one of the projects 2 of my students did.
Hola, Ponky. Hola, Pops. Yo estoy bien. ¿Y alguna vez te intrigó ver qué hay en la superficie? Yo sí. Ay, mira, ahí hay justo un bote. Podríamos ir a preguntarle.
We not only learn about coding, but they also learn about skills. So I'm going to skip some slides to share with you some practical tips for education. Keep activities open-ended to encourage exploration. Allow students to lead their learning process. Use Scratch Junior as a storytelling, arts, math, literacy, and science tool. Possibilities are a lot. Thank you very much for joining me on this presentation. You will be able to download the printable version for this activity, and let's connect. I am in Argentina and I would like to share all the things we do here in Argentina with the rest of the world. So let's keep in touch. You can write through that email or follow me on any of the social medias from Code and Play. Thank you very much.
Hello, my name's Rachel Klein, and I'm an ICT specialist teacher in the Cayman Islands. I'm here to talk to you about designing for a real audience with my Year Sixes working as digital creators. So my first slide. Basically, I'm excited to share a project that's become a real highlight of our school year. It's a creative coding journey where my Year Six students, they become game designers, web developers, and perhaps most importantly, they're creating for a real life audience. Moving to slide 2. The big idea. When students code with purpose, we get real motivation. And basically, like a lot of teachers, I've seen how much Scratch can engage students, but I wanted to go one step further, and I wanted my students to create for someone else. So basically, we gave them real clients with the children in Key Stage 1. The students started the project by interviewing their little web clients to find out what they liked, what made them laugh, and what kind of games they enjoyed. The answers ranged from unicorns to sharks, to do with anything to do with slime. Moving to slide 3. So the project overview is that this took place over the summer term, and the challenge was simple but powerful. The year students had to design and code a selection of games specifically for that little child that they interviewed in Key Stage 1, their web client. They had to create a welcome message in Scratch, a Pong game, a chase game, and a colouring game, all based on what their web client was interested in. Once the games were ready, we added a second layer where they had to build a website, and that was their web development challenge. So using code.org with basic HTML and CSS, the students had to then build their websites, and this further stretched their coding skills. It took a lot of patience, curiosity, a lot of debugging, trial and error. And then once the websites were created, each Year 6 students then added web links to their Scratch games into their websites for their students to enjoy. Moving to slide 4. We've got a little video here that I would just like to play of an interview going on, the children interviewing their little web clients. So if we'll just watch this for a moment.
Are you going to ask your client a question? Oh, it's your brother. Ooh, Stitch and Lilo, that sounds good. Very nice. Abigail, you're doing a good job there.
That is yum. Yum, love cow foot.
Do you love cow foot soup? Awesome. Oh, this looks a fun game. Excellent. That's a great idea.
So working on a project like this, it encourages collaboration and empathy. The children learn how to communicate through code. They can take feedback and use it. And they feel a real sense of pride in creating something with meaning. And honestly, these projects are some of the most exciting and hugely engaging for my Year 6 students. Moving on to slide 5. So just to think about some of the designs for younger users, the students had to think about whether a 6-year-old could read and understand the instructions, were the controls intuitive, and would it hold their client's attention? My student here was thinking about simple instructions, big buttons, bright colours and sounds, easy wins and fun feedback. Moving on to slide 6. I've just put a few examples of some of the projects that the students made. Sarah kept to a very specific cloud theme, and she created all her own artwork. And one of the comments she made was, I felt like a teacher showing the little ones the games that I had made, and I want to inspire them to make their own websites one day. Moving on to the next slide. This one was made by Mason, and Mason turned his website into a quest adventure. If you click on any of the pictures in the presentation later, it will take you to the students' websites. I'm moving on to slide 9. So this is just, this tiny little clip just gives you a chance to look at the level of engagement and excitement. So if you just click on the little video.
Do you like the game? Click the green flag. Run away, run away, run, run.
So my year 6 students had to act as tech support, game explainers, and of course, proud creators. They also had to do sort of problem solving in the middle of their presentations. I had one student told me my link didn't work, so I switched to another game that another student had made in the Scratch studio. So they were having to think on their feet as well when working with their web clients. Moving on to the next slide. This is just a little bit of feedback from the students. Izzy summed it up nicely. I had an amazing time as the little one played my games. I felt proud as I worked through many bugs and issues, but it came out well. Izzy's advice to someone starting Scratch, I would say never give up. Yes, I will admit my first time trying Scratch, it was hard, but I never gave up, neither did Mrs. Klein, me, the teacher. Moving on to the final slide. Resources you can use. If you're thinking of trying something like this in your classroom, you absolutely can. You just need Scratch so that the children can create the games, a basic HTML and CSS editor, and some curious young people, and ideally a real audience. It changes everything. If you click on the link, I'm the Klein Academy for ICT. It's my personal teaching blog. I've got loads of planning ideas, links, and website creation guides. And there's just one more little page, which is some feedback from the kids. It's a little difficult to read, but just to sum up, Coding with Purpose turned my students from learners into creators. When they had someone real to design for, they took ownership, they took risks, and they lit up. I'll end with the words of one of my year 6 students. I felt really proud of myself for making something really creative. I enjoyed the students coming to my station and enjoying the game that I had made. Thank you so much, everyone, for listening. And thank you to my incredible students for showing me what's possible when we code with connection. Thank you.
Hi, I'm Leilani.
I'm Hannah.
And we are here to talk to you all about exhibit and event design using Scratch. I'll let Hannah properly introduce herself.
Yeah, so I am Hannah Weiss. I am a STEM communicator, primarily in informal education settings. I'm a huge geek and I desperately want to be Miss Frizzle in my everyday life.
Oh, we all. I'm Dr. Leilani Dade. I'm an arts and media lab instructor at Trinity School in Oklahoma City. I'm a STEAM educator. I do Minecraft and gaming, as you can tell by some of my decor. And my background is in music and the arts, which will inform some of the material that I'll share with you today. The goal of our session is to showcase some ways in which Scratch can be used to create hands-on, engaging, and community-focused experiences in both formal and informal learning environments, which is a fancy way to say that we made some really cool projects, and we want to inspire you to make some cool projects.
And cool projects that span both schools and informal settings like museums, zoos, aquariums, all sorts of those spaces that learning also happens in.
For sure. My specialty is in schools, though. I'm a full-time teacher, and Hannah and I used to work at a science museum, so we've all done a bunch of different things. But here's my top 3 projects that I think work really well. The first one is Slinky Harp. I made this way back in 2019. This was actually made for an adult-facing event. So I think we're talking about schools. We mostly think of the children. But if you have a fundraiser event or an open house or family night, it's really cool to create some kind of a hands-on exhibit that they can interact with to showcase the types of things that students will be learning, but do it in a way that appeals to adult imagination. So in this case, this one had copper tape all over over it, so it wasn't super clear which ones would trigger the sequence and which ones wouldn't. And here, I probably won't play, that's okay. So in Action, you pull the slinky down and it connects to make the circuit. If you've ever played with music in Scratch, you know about 4 voices is where the layering starts to get a little glitchy depending on your browser and things like that. So we turned that bug into a feature. So we had the compositions, but once they layer, they start to act kind of pseudo randomly. So strongly recommend making big makey things with Scratch for public facing events in schools. If you're looking for one to do more long term with your classroom, though, the Scratch Arcade is a great place to start. I think almost everyone's first makey project is some kind of game controller, so I usually start there. It's a great opportunity to showcase student creativity, both through code and also things that are adjacent to code. So integrate lots of arts and STEM concepts into one event. And we had this with our art show, but you don't have to wait for a big school event to have it. You could just spontaneously pick a day for everybody to come play the games. This was one that I really wanted to include because we had a show where the choir wasn't ready. They didn't have enough, practices. There was a bunch of school cancellations. So instead of leaving them out entirely from the event, we made a Scratch choir game. I'm so sad we have to censor their faces because their faces are so funny for this. But I went around the school and took pictures of their default pose and then their silly singing pose. And so the families could come play the choir basically as an instrument, and it was a really cool way to include them without the pressure of a live performance. So one thing that Scratch is great for that I'm sure Hannah can agree with is it really helps reduce anxiety around code concepts. So my last one of my top 3 is a giant playable and reusable guitar. So especially if you're a teacher, the budget is usually it's never as high as you want. So you tend to use the budget on the things like the electronics, and then the rest you kind of have to just make it work. So I happen to have a hookup at this time for gigantic tubes, cardboard tubes, and that disappeared. So this is my only opportunity to get these. So I've made the guitar and I made it really durable so that we could reuse it over and over and over again. So it was a Battle of Bands Christmas skit. It was in a space themed art show, hence the Far Rock Cafe. And most recently, I finally hooked up all the frets to be playable. If you're a music person, you'll notice that I should have done 13 instead of 12, but so I could get the octaves. But it tended to be a full chromatic scale at about the correct intervals that a luthier would use to build the guitar. So I'm sure it'll be reinvented over and over again. But if you're going to make something big like this, and it's now I'm sad video. Oh well. I'm 5'7", so I'm not that small, and this thing is gigantic. So it's really cool hands-on thing for the students to use. Key takeaways: if you're going to be building Scratch-based projects, especially on a large scale for schools, use Scratch's built-in features. There's a lot of accessibility features in Scratch that Hannah and I actually did a presentation 2 years ago about, and normalize Scratch as an option for students who maybe struggle with text-based code. One of the things I see that I don't like so much is framing Scratch as something that's just for little kids. So if you frame it as just an easy, stress-free, accessible thing that students can do, if they're not ready to fully jump into Python or something, is a great option. And then consider the height and the mobility of your audience members. I don't know if you've ever personally been the victim of your own planning where you plan something and then realize the visitors are 5 and they can't possibly reach it. So try to avoid that. If you have wheelchair users or just any kind of mobility issues, make sure it's easy for them to interact with, as well as magical for them to experience. And then for large installations, which is what I like, the simple code is usually the best code. My code is not complicated for the music ones. The composition can get a little tricky, but the code is input, output, basically. If you get a makey or some other circuit kit and a bunch of miscellaneous materials, that's really all you need to get started. We'll give you a more detailed list later. And my suggestion for game design is to let loose your strongest coders on the game design elements themselves, and then allow other students to use their emerging code knowledge to make informed choices about the hardware, the design, what game is your friend creating, so what kind of controller would best serve that, how are we going to make the casing for the arcade game and things like that. So that way they can be exposed to it, but they're included equally, and there's not a hierarchy of like who's the best at code and who isn't. And then finally is let it go. Nothing lasts forever. Expect your builds to decay over time, sometimes within hours, sometimes within minutes, uh, especially if you're using tape and cardboard and these ephemeral things. Embrace imperfection as an opportunity for growth. And I really like to use Scratch, like I said, to reduce anxiety around computer science topics and spark moments of joy. The two pictures I have here are two of my wonderful coworkers who I shared with their permission. But they discovered that they could high five each other and create an interval on the guitar, and it was a very joyful moment. So we'll hand it over to Hannah now to talk about museum and public facing examples.
Yeah, so really interestingly, a lot of the things that work for a school are also really important in museum settings. You really need to make sure that things are going to stand up to what you need them to, and also how you're building them. But one really interesting facet of building these types of things for a museum setting or an informal education setting is you have this added piece of, is it going to be facilitated? Are you going to have a person there with it? Or is it going to be unfacilitated? And you have to consider the number of guests that are included. So for some events, you might have 500. For some events, you might have over 1,000. And so the materials you use and build with are really important to consider in that moment, as is the challenge or the difficulty of the code you use. Similarly to what Leilani shared, that simpler code is often much better. If you want to pass to my next. So one really cool example of us using a Makey, and actually Leilani and I were still working together for this one, was we made a pumpkin organ for a Halloween event. So it was designed for a Halloween event. It was our spooktacular and not so scary Halloween, largely designed for younger audiences, but we wanted them to have an opportunity to explore music, and particularly the science of music. And so we built a pumpkin organ very simply using Scratch, but also in doing that had to problem solve. Because as we were testing with our staff, some of us were able to activate the pumpkins and some of us were not. And we found that it had to do with the like dryness of our hands. And so we add some blood slime to make sure that it was usable. So especially when you're considering engaging and using Scratch to build these things that are going to be used and explored in large settings, you have to consider multiple users and all of the different problems that might come up. If you want to go to my next one. We also did a really amazing Harry Potter themed, let's say, event. It took over the entire downtown of the city that the museum was in. So we wanted to make an unfacilitated station in which people could pot and repot a mandrake. So because this was going to be unfacilitated, it was something that needed to be able to stand up to approximately 1,200 visitors and not need troubleshooting. So again, that's one of the things that we had to look at. How difficult or complicated is the code? We wanted to make it very simple, although this particular one, because it was engaging when you picked something up rather than push something in. So with Scratch, it is very easy to make something happen when you push something. It requires a little bit of backwards thinking to make it happen when you unpush something. We had to test in multiple phases. So in building these types of things for public-facing settings, Scratch is a great platform because it allows you to really quickly, rapidly prototype and get the code down before you have to make sure everything works. So with rapid prototyping, this is something that I used very recently. I'm currently working at the Exploratorium, and we have a really fantastic summer show all about artificial intelligence. And we have a large team of early career educators who are facilitating this show. And we have a space where we wanted them to develop the activities. So in addition to a number of exhibits, we wanted them to develop facilitated activities that would allow our guests of all ages, from like very, very young kiddos all the way through. We have a weekly adult only event to be able to engage with different things in AI. And the way that we did that was used Scratch. You've got it, Leilani. So using Scratch in museums is really, really beneficial because it creates hands-on opportunities for learners of all ages, needs, interests, and provides those access points. As Leilani shared, Scratch is super accessible. I personally am dyslexic, so Scratch is a great way that I can code, even when I'm having trouble decoding text. However, when we're doing this in museums and in these large public settings, we do have to keep in mind things are going to wear out and break. So when you're building the larger components of what you're doing or engaging, even if you're using Scratch and a computer, you really have to think about how is that computer being accessed? How are people engaging with it? And how are we making it safe to be in a facilitated or unfacilitated setting? How are we locking it down? We have to be prepared to troubleshoot, check in frequently, and train people to be able to troubleshoot. And understand both the limitations and wonder of Scratch and the materials. Scratch, for example, is really internet dependent and really device dependent. And in some spaces, you can't use a device safely on the floor because there's no one who's got eyes on it. And that does not necessarily mean you can't use Scratch to build something. So we wanted to leave you all with a starter pack of how you can use Scratch in your settings. So the very first question in our starter pack is, how can you use Scratch in your settings? What resources do you have already? What resources do you need? Who is your audience? Who are you building this for? What are your goals? How large is your audience? And how are they going to be interacting? So a lot of really important things to consider, especially for me and Leilani, when we were building all of this out, was what are the materials that we have? Just like teachers don't often have the largest budgets, nonprofit institutions don't often have the largest budgets. So we use a lot of cardboard, bottles and bottle caps, tinfoil, miscellaneous conductive materials. You'd be surprised at how many things are conductive when you test them.
Slinkies, for one.
Slinkies. Lots of museum store product. And then thinking about your electronics. A laptop or a computer is really useful. So is a touchscreen device or a tablet. Makey-makeys are something that we've used a lot. As our Pico boards, I've used some. Cameras can be really valuable, and microbits are something else that can be really valuable.
Well, thank you so much. If you'd like to connect with us on LinkedIn or email, there you have it. But thanks for listening to our presentation.
Yeah, thank you for letting us share. Oh my gosh, Leilani, like almost a decade at this point.
Yes.
Of working together with Scratch in so many different settings.
Yes, thank you.